PCR technique, which is developed by Cary Mullins in 1983 and he got the Nobel Prize in 1993. In this technique, we can multiply a specific DNA with a certain length up to 500 base pairs or more than that. In this case, we can have the double-stranded DNA fragment, or we can also multiply from the chromosome. In this, we have the three steps. In this first step, we can denature the DNA fragment. In the second step, we can anneal the DNA fragment. After that, in third step, we can do the DNA polymerization. In the denaturation, we can use the 92 to 95 degrees centigrade. At that temperature, the two DNA strands will be separated. At that condition, the hydrogen bonds will break and the two strands will be separated. After that, we can add the DNA primers of complementary in the left and right borders of the respective single-stranded DNAs, and they will be annealed at 55 to 60 degrees centigrade. And after that, we need to add the DNA precursors in the form of the DNTPs, magnesium plus 2 ions and buffer solution. After that, we can heat at the 75 degrees centigrade and we can add the Taq polymerase for the DNA synthesis. In this case, the DNA polymerase, which is extracted from one of the bacteria, Thermus aquaticus, it is each stable. Because of that, when we changing the temperatures in the thermal cycles from the 72 to 92 and also 55 degrees centigrade, in these thermal cycles, the DNA Taq polymerase won't be denatured. Because of that, we need not add the again and again the DNA polymerizing enzyme. And in this, the PCRs may be in the form of the useful to copy the DNA. First single DNA will be converted to 2 DNA fragments in the second cycle in the form of the 4, and after that in the form of the 8 fragment, 8 into 16, 16 into 13 to 32 into in the form of the 64. Within a short time, we can clone the DNA fragment in the form of the machine mode, and it is useful in case of the DNA sequencing and also to identify any variation is there in between any two strains of the bacteria or any other thing plants we can analyze. And also we have the PCR known as the RT-PCR. In this case, we can use the mRNA will be converted into form of the DNA in the form of the hybrid DNA RNA. The RNA will be digested with RNase enzyme or alkali condition, and the single-stranded DNA will be converted into double-stranded DNA. In this RT-PCR, we can also develop the cDNA libraries, and in these cDNA libraries, we can have only in the form of the gene sequences. In addition to that, we can also have the real-time PCR. In this case, real-time PCR, which is useful to how many times the DNA is copied. In this case, one of the strand is binded with the probe molecule and consisting of in the form of the one quenching molecule and a fluorescent molecule. While it is synthesizing the DNA, the quenching molecule will be broken, and after that the fluorescent molecule is fluoresces. Because of that, how many times the DNA is duplicated, it will be quantified in the form of the real-time PCRs. All these PCRs which are useful to in the DNA fingerprinting techniques or to analyze the any strains which is useful. The PCR technique which is very much useful, and we can multiply the fragment of DNA, particularly in case of the forensic medicines where we get the less samples of the DNA by using the hair follicles or blood samples, we can isolate the DNA and we can multiply it and we can determine the who is responsible specific crime. So this PCR technique which is useful in several ways. Thank you.